last question on this test is question 6, and it's a beautiful relative atomic mass question again. So, first of all, we've got a mass spectrum. Which isotope of Y is more stable? Well, more stable means it's more abundant because it hasn't broken down as much. So therefore, we'll say Y63 is more stable because it is more abundant. Use the information in the mass spectrum to determine the percentage abundance of each isotope and hence calculate the relative atomic mass of element Y. Okay, percentage abundance. So percentage of Y63. We take the amount we have, so which is 124 random units. We divide that by the total, which will be, if I get this again, and that's going to be 124 plus 56 gives me 180. And that times it by 100 to get the percentage. So therefore, 124 divided by 180 gives me 68.9% for element or isotope 63, and Y65 is going to be equal to, 56 divided by 180. So 56 divided by 180 gives me 31.1%, and I should have known that because it's just 100 take away that. Anyway, let's move on. Relative atomic mass equals the sum of the percentage times mass. So that equals to bracket 63 times my percentage, which is 0.689, plus what's this one? 65 times 0.311, and then I bang that into my calculator. So 63 times by 0.689 bracket plus bracket 65 times 0.311 gives me 63.6-ish AMU. Alrighty, what is the identity? I go to my periodic table and I look at what this is, and I'm pretty sure it comes out as being copper. Give or take, I think copper is actually 63.5, but it's the closest thing on the periodic table to that. And that is how you do this question here, where you're given a mass spectrum and you have to identify the relative atomic masses. You first of all work out the percentage by looking at what percentage is this of the total, and then what is the percentage of that of the total, and that's the answer. That is the entire test done and dusted. Hopefully this helps you. Obviously, if you have any questions, let me know.